Hello students, so we're back again with a new video, and today we are going to learn about Laplace transform of derivatives. Like any other problem of Laplace transform, we are beginning this proof or problem with the definition of Laplace transform. So what is the definition? Laplace transform of f of t is equal to 0 to infinity e raised to minus st f of t dt. And since we are taking the Laplace transform of a derivative, I can just write it as f prime of t, and if this is f prime of t, this also will be f prime of t, right? Okay, so let's begin with the solution. So now, to integrate this, we have to use integration by parts formula. And what is that? U into dv is equal to uv minus integration v into du. We have done this in the previous videos. So now is the time to choose what is u and what is v, right? So let's choose u. I will choose u to be equal to e raised to minus st and v to be or dv to be f dash of t. So what is du? Du is differentiation of e raised to minus st, e raised to ax. Differentiation of e raised to ax is e raised to ax into a. So here I have e raised to minus st. So it is e raised to minus st into minus s. So what I'll do is I'll take minus s to the other side. So I'm going to write it as minus s e raised to minus st. So this is my differentiation of u. And what is v? Integration of dv. Integration of a differentiation of a function is a function itself. So this is the differentiation of a function. So if I integrate, I'm going to get the function itself. Right? Now substitute in the formula. So we have integration 0 to infinity e raised to minus st f of t dt is equal to, right? So this is our LHS. So what is our RHS? U into V. What is U? E raised to minus st into f of t. But since it is a definite integral, I'm going to apply the integrals, right? Minus integration 0 to infinity. What is v? F of t. And what is du? Du is minus s e raised to minus st dt. Apply the limits. So we have this is equal to e raised to minus infinity f of infinity minus e raised to 0 f of 0 minus c. S, since the integration is with respect to t, s is going to remain a constant part. So this constant is going to come out of the integral sign. So minus into minus is plus s. Integration 0 to infinity. Now I'll rearrange this and I'll write it as e raised to minus st f of t dt. Right? Now what is this? E raised to infinity is 0. 0 into anything is 0. And minus e raised to 0 is 1. 1 into f of 0 is f of 0. But since we have a minus sign, I'm going to write it as minus f of 0 plus s. What is this? This is a definition, that is Laplace transform of f of t, not f prime of t. We have f of t. So we have, in the first video itself, I have told you the definition of Laplace transform. We can write it as Laplace transform of f of t is equal to capital F of s or f bar of s. Right? So here I am going to denote this as f of s, capital F of s. So this is going to be f of s. Right? So if I just rearrange this, so what is my RHS? It is going to be s into f of s f of 0. So let's write what is Laplace transform of f prime of t. This is equal to s f of s minus f of 0. So this is for the first derivative. Now what happens when we try to find out the second derivative, third derivative and so on for the other derivatives? So what is the Laplace transform of higher order derivatives? So if we go to see that, we have Laplace transform of f double prime of t. This is going to be equal to s square f of s minus s f of 0 minus f prime of 0. And if I go for the third derivative, third order derivative, it's going to be f triple prime of t. This is equal to s cube f of s minus s square f of 0 minus s f prime of 0 minus f double prime of 0. So if you see this, there is this pattern being followed. So what is the pattern? See here, in the first derivative, we had first order of s and directly f of 0, plus we also had the Laplace transform of f of t, right? And in the second derivative, we had the second order of s followed by first order of s and no s, right? And then we had the Laplace transform of f of t. Then we have the f of 0, f prime of 0. Here same thing, s cube, s square, s and no s, right? And here we have f of s, this is the Laplace transform of f of t. Then we have f of 0, then it goes on continuing, f prime of 0, f double prime of 0. So if you see here I have triple prime and here I have double prime. When I have triple derivative, I have the order to be 3 for s. So let's try to write for the nth order. So that is Laplace transform of dn by dtn f of t is equal to. So the nth power is going to remain the same for s. So it's going to be s to the power n f of s, right? And the power of s is going on reducing. So it's going to be minus sn minus 1. The second term is always f of 0. So this is going to be f of 0. And again, the order of s is going to decrease. So minus sn minus 2. And what happens to f of 0? It starts with f prime, f double prime and so on. So I have f prime of 0. So if I continue like that, I will get s to the power of 0, or I can say no s, minus of f to the power n minus 1 of 0. See, here it was 3, here 2, here 2, here 1, here 1 and here 0. Right? So similarly, here I have the nth derivative. So here I will be having n minus 1. So this is the general formula for Laplace transform of a derivative. Let's solve some examples so you will have a clear idea as to what this is. Alright? So let's start with the first one. So the first problem is we have to find the Laplace transform of t square using the derivative formula. Alright? So let's take this as Laplace transform of t square. We will keep it like that. Okay? And we will just say that f of t is t square. Okay? F of t is t square. So what is f of 0? It is going to be 0. And what is f dash of t? It is derivative of t square is 2t and f dash of 0 is 0. Okay? And if I again differentiate it, I am having f double prime of t. This is equal to the differentiation of 2t. Differentiation of t with respect to t is 1. So 2 is a constant. So into 2, I am going to get 2. and f double prime of 0 is 2. Now let me differentiate this again. So what I have, f triple prime of t, differentiation of a constant is 0, and here I have f triple prime of 0 is 0. Right? Now what I'll do is I will apply the formula, or I can say Laplace transform of f triple prime of t. This is equal to, okay. Now what is this equal to? S cube, the same, right? F of s, right, minus s square f of 0 minus s f prime of 0 minus f double prime of 0. Now we have to find out what is Laplace transform of t square. So this f of s is denoting nothing but Laplace transform of t square. So this I am going to keep it as it is, and I am going to solve the remaining part. So what I have here, Laplace transform of f triple dash of t. F triple dash of t is 0. So Laplace transform of 0 is 0. Right? And I'll just write it this side. So 0 is equal to s cube f of s minus s square f of 0. F of 0 is 0 minus s f prime of 0 is also 0, and minus f double prime of 0 is 2. So this is going to be s cube f of s minus 2, or s cube f of s is equal to, this minus 2 comes on the other side, becomes plus 2. So what is f of s? It is 2 by s cube, or I can say Laplace transform of t square is equals to 2 by s cube. And this is what is required. Okay. So you have one more formula where you can directly find out what is Laplace transform of t raised to n. Right. But when you are asked to solve the Laplace transform using the derivative method, you are going to do this. Okay, so you have to remember this pattern. If you remember this pattern, solving this is going to be simpler. Alright, we'll go to the next one so that you will understand more about how to solve this. Okay, the second example. The second example is Laplace transform of t sine t. So we are going to first write down what is this? Laplace, or we can say f of t is t sine t. So what is f of 0? It's going to be equal to 0, because t 0 into anything is 0. Right? So what is f prime of t? So we have to differentiate it with the product formula. So right? So t is going to be constant, and you are differentiating sine t. Differentiation of sine t is cos t, plus sine t is kept constant. Differentiation of t is 1. So it is t cos t plus sine t. So what is f prime of t? See, f prime of 0. Okay, 0 into anything is 0, and sine 0 is also 0. So f prime of 0 is 0. Okay, f double prime of t. So this is going to be what? Again, this will be a product formula. So what I'll do is I'll first differentiate this, and then I'll differentiate this. Differentiation of sine t is cos t, plus t I'm keeping constant. Differentiation of cos t is minus sine t, plus cos t I'm keeping constant. Differentiation of t is 1. So I'm keeping it like that. Right? So what is f double prime of 0? Cos 0 is 1. 0 into anything is 0, plus cos 0 is 1. So this is going to be equal to 2. Now I'm not going to again differentiate it because we're going to get back the same things again and again. Cos t will become sin t will become cos t. So there's no point of differentiating it again and again. So we'll stop here. Okay. So then what we'll do is we'll take the Laplace transform of f double prime of t. So Laplace transform of f double prime of t. Okay, this I can also write it as 2 cos t minus, what is this? T sin t. Okay, right. So Laplace transform of f double prime of t, this is equal to s square, same thing, f of s minus s f of 0 minus f prime of 0. Okay, here 2 we have, here 1, right? 2 and 2, right? So let's go on substituting. Laplace transform of 2 cos t minus t sin t. So Laplace transform of 2 cos t minus t sin t. This is equal to s square. S square f of s. So s square f of s, I am going to keep it like that, minus s into f of 0. F of 0 is 0. So it is going to be 0. And f prime of 0 is also 0. So I am going to keep it like that. Now here I can separate them. So it's going to be 2 Laplace transform of cos t minus Laplace transform of t sin t is equal to s square f of s. What is this? This is also f of s because it is nothing but f of t. So I have 2 Laplace transform of cos t minus f of s is equal to s square f of s. Now if I take it on the other side, I have s square f of s plus f of s. So I have 2 Laplace transform of cos t is equal to s square f of s plus f of s. So if I take f of s common out, I am getting s square plus 1 f of s. Laplace transform of cos t is s square upon s square plus 1. And I have a 2 here. So 2 into s square upon s square plus 1. This is equal to s square plus 1 of f of s. But I want f of s. So this s square plus 1 comes down. S square plus 1 into s square plus 1 is s square plus 1 the whole square. So f of s is equals to 2s square upon s square plus 1 the whole square. Therefore, Laplace transform of t sin t is equal to 2s square upon s square plus 1 whole square. So this is how I'm going to solve this. So this is the main part of our problems. So let's quickly do the third one, that is Laplace transform of t cos t. So what is f of t? F of t is t cos t and f of 0 is 0. Although cos 0 is 1 but t is 0. So 0 into anything is 0. Right? F prime of t will be, t is constant, differentiation of cos t is minus sin t, right, plus cos t into 1. Okay, so what is f prime of 0? This is going to be 0 plus 1, that is 1, right? F double prime of t is going to be, again I have to differentiate this. So it is minus of, okay, I'll take the minus outside, t sin t, t is kept constant, differentiation of sin t is cos t plus, okay, sin t is kept constant and I have t, and differentiation of cos t is minus sin t, right? So if I take everything inside, I'm going to get minus of t cos t minus sin t minus sin t. So that is going to be minus t cos t minus 2 sin t. So this is my f double prime of t. So what is f double prime of 0? 0 into anything is 0. Sin 0 is 0. So this is going to be equal to 0. So what is our next step? The formula. That is Laplace transform of f double prime of t is equal to s square f of s minus s f of 0 minus f prime of 0. So this is Laplace transform of t cos t plus 2 sin t. I will take it as, so minus, I am going to remove it outside. Okay, so this is equal to s square f of s. I am going to keep it like that, and minus s into f of 0 is 0 and f prime of 0 is 1. So it is going to be minus 1. Now here Laplace transform of t cos t minus Laplace transform of t cos t minus 2 Laplace transform of sin t is equal to s square f of s minus 1. So this is again f of s. So this minus f of s comes on this side. It becomes plus f of s, and this minus 1, I just bring it on the other side. So what is Laplace transform of sin t? Laplace transform of sin t is 1 by s square plus 1. So it is minus 2 by s square plus 1. Right? And this plus 1 comes on the other side. When minus 1 comes on the other side, it's going to become plus 1. This is f of s. So this is equal to s square f of s plus f of s. So it's going to be f of s is common out, s square plus 1. Right? So when I bring it down, I'm going to get it as minus 2 by s square plus 1 the whole square plus 1 by s square plus 1, and this is equal to f of s. Or I can simplify this as s square plus 1 the whole square, and this is minus 2. I'll just take the LCM. So I have plus s square plus 1. Minus 2 plus 1 is going to be minus 1. So I'm going to get it as s square minus 1 upon s square plus 1 the whole square. And this is f of s, or Laplace transform of t cos t is equal to s square minus 1 upon s square plus 1 the whole square. And this is our answer. So we followed all the same steps, right? Find out what is f of t, f prime of t, f double prime of t, f of 0, f prime of 0, f double prime of 0. Substitute in the formula and you will get the answer, right? In our next video, we will see how to solve the differential equations using the same formulas. Alright, so if you have any doubts, please comment in the comment box, and if you like my videos, do like it, subscribe it and share it with your friends. Thank you.